Okay, this is section 4.4. It's called finding an equation from its graph. So what we're going to do is we're going to take a trip down memory lane and think about Algebra 1 when we had just a linear line, and how did we find the equation of that line? Well, a lot of you might be thinking y equals mx plus b. Okay, so that's our general equation that we use for this type of problem. And if you can find your slope and find your y-intercept, this becomes quite simple. So what is our b, or our y-intercept? It's 0, 2. So I know that my b is 2. And what's my slope? Down 1, run how many? 2. So I know my m is -1/2. And then you literally just plug these equations in. So that's the main idea of what we want to do for section 4.4, except instead of linear lines, we are going to do trigonometric equations. So what you might want to do is have your blue sheet out so that you can kind of refer to the general form equation. So y equals, it's a, and then you can interchange sine, cosine, tangent. I'm just going to say sine of what? B, x minus c plus d. Okay? So a refers to your amplitude. B is involved with your period. It's not the period, it's involved with your period. C is your phase shift. D is your vertical shift. So what's going to happen is, now some of you might get very excited when I say this. Some of you are going to puke. Is there are literally infinitely many different solutions for every single one of these problems. Okay? Especially a curve like this. I'm going to say, can you write me the equation of this curve? Well, you could say that this curve is sine. You could say this curve is cosine. And since this thing is periodic, you can literally shift this thing as far or as least as you want to, depending upon your desire. So, like on a quiz or test, you literally can make my life very, very difficult if you wanted to. And if you really want to, go for it. Okay? If you want to make my life simple, that would be neat, but you kind of got to make that call. So, I want you guys to look at this. I am going to go way out on the limb that says, hey, this thing starts at 0. A lot of you might want to say, hey, this is sine. Okay, and I hope that you kind of look at that and say, yeah, I think so. I could do this as sine. Here's what I'm going to do. Every single problem I do, I'm going to draw a line that cuts my graph in half. Okay? Just so that I know, and why I do this is to see if there is actually a D, a vertical shift. So in this case, I'm going to say absolutely no vertical shift whatsoever. Okay? And then I'm going to decide sine, cosine, which one do I want? I'm going to do sine first, and then I will do cosine. Okay? So for sine, it starts there, so I'm good. What's my amplitude? I move on to A. What's A? Okay? So A involves distance from the middle line of mine to the very top or to the bottom. So it's 3 away, so I know my amplitude is 3. Alright, I also need to figure out my B. My B refers to, remember that period equals 2 pi divided by that B value. So in this case, let's see here. What do I need to do? Period start, so I go through, go down, go back, and I finish right here. So what is that distance to where I start to repeat? Well, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which reduces to 2 pi. So my period is 2 pi. What does that make my B value? Okay, you literally can set this up and cross multiply, and it ends up being that B in this case is equal to 1. Okay, so I know that I have my D is 0, my A is 3, my B is 1. The only thing I have left is a C. Well, if I want to do sine, if I'm going to deem sine x, is there a phase shift? I start here, it goes up. I do not need to do a phase shift at all. So my C value is actually nothing. So if I want to write an equation for sine, I would say y equals my A value is 3 times sine of my B is 1, my C is 0, and my D is 0. So literally it's 3 times sine of x. Alright? What happens if I want to write cosine? Okay, cosine always starts at its peak. So what I look for on a graph for cosine to make my life easier is, where is the peak? And then how far do I have to shift over to get to where, i.e. the parent function, would have actually started. Okay, so that's kind of the idea that I'm looking for, is how far over would it need to go? Well, in this case, I need to shift my graph left pi over 2. Okay, so in this case, my A value, not changing. The B value, not changing. D, it's not shifting up or down any. I just want to move this thing left, okay, pi over 2. So I just need to literally insert. The only thing that would be added is C equals pi over 2. Okay, so how would I end up going about doing this? I would say that y equals 3. And then in this case, it's cosine x minus pi over 2. Okay, and I kind of maybe said this a little bit backwards. So the original guy's here. I need to move it, okay, right pi over 2 to get where it is. I know I kind of phrased it as I need to move this guy left. Technically, you probably should start from the parent function and say I need to go right pi over 2. So here's another option for you. So what I'm going to do is I'll do another one with both of them on this one, and then I'm going to do cosine from now on because I like cosine better because it's just easier. Okay? So the first thing, what am I going to do? I'm going to cut this guy in half just so I can kind of see where I'm at. Now in this case, it's cosine is kind of the obvious one because at 0 it's at its peak. So I'll start with cosine on this one. Alright, what's my amplitude? My A value, I probably should be using capital letters for this stuff too, just to not throw you guys off. Okay, my A value, how far from the middle up and or down? 1 unit. Okay, my B. To calculate B, remember that has everything to do with the period. Here's where I start. Here's where I finish. It's pi units. So how's that going to affect my B? Some of you might be able to do this off the top of your head. Others may need to do this. Period equals 2 pi divided by B. My period is just pi. Alright, now if I cross multiply, pi times B equals 2 pi times 1, and divide by pi, B equals 2. Okay, so I know A is 1, B is 2. I'll save the phase shift for the end because that has everything to do with what kind of problem you have. And then D, does this thing shift anywhere? Normally my middle should be right on the x-axis. This time my middle is 1 unit up. So that means my D value is 1. So now what I want to do is I'm going to do cosine first. So if I decide that I want to write an equation for cosine, I have to go y equals, my A value is 1. I don't have to write that one. Okay? Cosine B, now if I go back to my original formula, so you might want to be looking at this as I'm doing it. My B is 2. Alright, I'll talk about C in a second. And my D is 1. Okay, so cosine of 2, and I'm just going to write this now, x plus 1 is my actual answer because I know my B is 2. I don't need a C in there because cosine starts here. Okay, so it's not needing to shift anywhere to my original parent function. Okay, so that would be cosine x and then plus 1 because of the up. Now that is if I decide to go with cosine. Once again, I feel this is a lot easier to just do cosine because all I'm looking for is the peak of my graph. And then I know this thing is going to go down, so it's going to take the same general shape. Why is sine difficult? Okay, because you need to find where the line hits this dashed line that we put in there. So let's say, for instance, I decided to pick the first time my graph hits that dashed line. This is where my quote-unquote sine curve would start. Well, what's the problem? First of all, I say usually sine goes up and then down and then back. Well, this time it's flipped. So technically, I have to do negative sine. So let's say I wanted to do sine x. Okay, I would be y equals, amplitude's not changing except I'd have to go negative sine of 2 x plus or minus something plus 1. Okay, because I'm still going to have that vertical shift up and my B value is still going to be 2. That's not going to change. I had to put that negative sign because it starts down. Now originally sine should start here, but it's actually starting there. So I had to move it how far to the right? pi over 4 to the right. So I'd have to insert a minus pi over 4. Alright? That just becomes, I think that's just more difficult starting here. Now some of you are like, what if I don't want to do the negative? You could actually start all the way over here and say, hey, sine usually starts going up. This guy's going up. So it's going to take the same a value of 1, but this time it's not going to have to be flipped. Positive sine. It's going to be 2x something. Still going to be shifted up 1, except now how far is it shifted to the right? This time it's 3 pi over 4 to the right. So I just showed you, hopefully I didn't completely confuse you, but I just showed you 3 different possible answers for this one simple problem. Okay? All I'm going to look for is one of them. And more times than not, I feel like cosine is by far the easiest one to do. Okay? So it's just a matter of finding A, B, C, and D and dumping them into your equation. Alright? Oh my goodness. Here we go. I have tangent or cotangent. Which one do you guys think? Well, technically it could be either of them, but I want you, more times than not, I told you we're really only going to deal with tangent a lot in this class. So I'm going to write this up here. Y equals A tangent B. Your general form equation. Okay? And I want us to figure out all of these things. So, first and foremost, does this look like tangent or cotangent? Now remember what I talked about with tangent. I have a cage on each side of 0, okay, and it falls in between. Normally tangent looks like this. I hope that you guys would pick up on that tangent usually looks like this. Okay? But we can make the change, is just that the appropriate thing is that these asymptotes, my cage, like I like to tell you, is in the correct spot. So I'm comfortable using tangent with this problem. Okay? What we need to figure out now is what is in between. What are we going to do? So, amplitude. The A value. Let's start there. Now, usually okay, halfway in between, I said we're 1 up, okay, or 1 down on this side. Is that still the same? Yes. So I can be comfortable saying that my A value is 1, except usually tangent's here, and now it's up there, or it's usually here, and now it's down there. How do I make that change? Excuse me, we need to just have it flipped. And how do I have it flipped? We just put a negative sign out front. Okay, so I know that in my equation, and I could even start the equation, I'm going to know that it's negative 1, okay, tangent. Alright, what's my B value? Now, B value refers to the period. So period in this problem is how far from cage line or asymptote to asymptote. Negative pi and then pi. So 1 pi, 2 pi. So we got to be careful though. Period in tangent equals just pi over b. So my period on this problem is actually 2 pi units long. Now what does that make my b value? So I'm going to cross multiply. 2 pi times b equals 1 times pi. And then I'm going to divide 2 pi out. So they're all gone. B equals, pi's are gone. I'm left with 1/2. So I know that my B value is 1/2 x. Now, is there going to be a phase shift at all? Are my asymptotes on the correct line? And hopefully we can say yes, because we have half on each side. So I have 0 phase shift, or my C value ends up being 0. And then D value, it still starts at 0. It cuts through at 0, so it's not shifting up or down any. So my D value is also 0. So I know A is 1 and it has to be flipped. B ended up being 1/2. C and D both end up being 0. So there's my equation for tangent. Alright? So let's go through a couple more of these. Now here's what I'm going to do. I'm basically, this could be sine or cosine. For the rest of this class, or the rest of these notes, I'm going to do cosine if it's just a sine or cosine curve. Okay? Some of you that like sine, you can try it. It's not going to be wrong. I'm just going to do cosine to save time for one, just because I think it is easier. So as I go through this, I have to put that line through the middle. The reason I say it's easier is this isn't necessarily easy to see where sine is. So here's what I want to do. I need to figure out A, I need to figure out B, I need to figure out C, and I need to figure out D. So I'm going to put my general form up here just for you guys to note again. Just know that this is on your blue sheet if you want it. Okay, amplitude. From the middle line to the top and or the bottom, I know my amplitude is 2. And I'll worry about if I want it flipped or not in a second. I don't need a flip because it's cosine. I know I can either go there or there to start, so I'll be good. The B value, I have to go through this and check it. So here's where I start, which it's going by pi's over 4. So starting here and then going and stopping at 7 pi over 4. Well, how far is that? 1 pi over 4 and 7 pi over 4 more. That ends up being 8 pi over 4, or 2 pi is my period, which you guys hopefully now know that that is the normal period. So for that to happen, if you cross multiply, my B has to be 1. Okay? So my period or my B value is not changing. D, is this, and I jump to D, I always do C last because that can change depending upon where you start. The D, is that going to go up or down any? Normally, my line is at the x-axis. Now it is 2 units down. So my D value is -2. And now it's a matter of which one would you like to pick? Okay, do you want to start here? If it is, how did I go from home base to get there? I had to go that many units to the left this time. So I would end up saying y equals 2, because that's my A, cosine of 1. I don't need to do that just because 1's not going to affect anything. And to move left, I would say plus pi over 4. Okay? That's what I would look for there. And then what? -2. So that would get me to start at this pink dot. Now some of you might say, hey, what if I don't want to have a plus? What if I wanted to start way over here just to mess with Wilson's head a little bit and make him think? Well, if that's the case, what do you need to do? You need to shift this thing 7 pi over 4 to the right. So I could say y equals, the amplitude's not changing. I'm just going to say it's x minus 7 pi over 4 minus 2. And you could literally, once again, have infinitely many different answers to start this thing. And that's how you would go about doing that. Only one of them's needed on a quiz or a test, though. Okay? So only one or the other would be needed. And yes, you could do sine. Yes, you could do negative cosine if you wanted to flip the thing. There's literally so many different ways that you could go about doing it. Okay? So now on this one, once again, it looks like sine or cosine. I don't know which one I really want to do yet. So I need to figure out, okay, I'm at 5 and at -1. Where does it cut in the middle? At 2. What if some of you can't visually do that? You can always add them together. Okay? 5 plus a -1 divided by 2. 4 over 2 is 2. That's how you can figure out your middle if you want to. It's just the average. Okay? So I now have something that cut my graph in half. Why do I like that? Because now I can find my amplitude. Amplitude's from this line in the middle to the top and or the bottom 3 units away. So I know my amplitude's 3. And then my B value. What do you guys notice your x-axis is going by? Just normal numbers, which means your equation's going to need to have a pi in it. Now, I don't know how many of you remember that, but here, okay, I start here. This is the only spot that I actually see a starting spot going through my whole curve to the ending spot. How far did I go here? That's my period. Start, go all the way through to go back up again. That's 6 units. Okay, so my period is 6. My equation is 2 pi over b gives me my period. What's my answer? Yikes. So I say 6b equals 2 pi times 1 because I'm going to cross multiply. Divide by 6. B equals 2 goes into 6 3 times. So pi over 3 is my b. Alright, so that's just my b value. What else can I do? The d. How far? Normally, cosine or sine's middle is at the x-axis. This time it is 2 units up, so I know that d is 2. So I always can get that a, that b, and that d without too much trouble. And now it's just a matter of plugging in however I want to. So where do you guys want the, I'm going to do cosine, to start. Normally, cosine starts at its peak, for instance, like this one, but on the x or on the y-axis, excuse me. So normally this point should be here. Well, how far did I move it over to get that far? So if I want a positive a value, I just need to move it over 3 units. Okay? So I could say that y equals amplitude 3 cosine, b value is pi over 3, and I just said I wanted to move it to the right 3 units to make it there, and I have to move it up 2. Whew. Craziness, right? How many of you, I don't know if any of you realize that the bottom of your curve, okay, it actually started right on the y-axis. Well, usually it starts at the top. This time it started on the bottom. You could, once again, options, drive some of you absolutely crazy, and that's what makes this section hard. Okay, you could have just said, hey, if my amplitude would just have a negative sign with it, I am starting right where I need to. No longer will I need a phase shift for it. So if I do negative 3 cosine, my b value won't change. The phase shift is no longer because I'm actually starting on that axis. So that is another option for you. Again, any of these are possible. Okay? So that's how we can go through and kind of deal with all of those problems. Questions on that? I hope not, but if you do, we will talk about it in class. The last one, the hard ones, okay? So if you have a secant or cosecant problem, now once again, this could be either or. You kind of need to decide which one you want to do, but you need to get those asymptotes put in. Okay, that part's not going to change at all. And you're going to want to try sketch in your parent function. Now we know that these all share, and wherever the asymptotes are, that's where it ends up being at 0. The problem is, yikes, that's what makes this one hard. Your middle line looks like it's at 1. Eee boy. So I know that my original curve, if I can do this correctly, looks like that. Well, what does that kind of look like? If I don't want to shift any, because shifting can get quite tricky for this thing, I'm going to notice that this thing actually does hit at the y-axis. So I would say that this deals with sine x, which means that we need to write a cosecant x equation for it. Okay? The problem is sine usually starts at 0 and goes up, but this time it's actually going down. So how do I deal with that? That means my a value is flipped or have a negative sign attached to it. And what is my amplitude? My normal, my middle is at 1, and I go up to 3 and down to negative 1. That means it's 2 units. So a is 2, and it has to be flipped. Alright, so that's how I can deal with the shape of the graph. What is my period? Well, if I start here, I go down, go all the way up and back down, that distance is 2 pi, which is nice. That means it's the normal one. My b is not going to change. My d value, my middle is not at the x-axis. It is 1 unit up. So that means my d value is up 1. My vertical shift is up 1. And then phase shift, do I have one? We decided to use sine. So no, we do not have one because it actually hits at the quote-unquote origin, or my 0, 0 starting spot. Okay, I know it's moved up 1, but it hits right at that spot. So I do not have to do that. Now some of you might say, hey, if I wanted to do secant, if you decided to do cosine secant, like shift this guy is supposed to be here or vice versa, then you would have a phase shift with the secant graph. Okay, but in this case I don't want to deal with that. I want to make it as easy as possible. This looks like sine. The only thing I have to do is flip it with the negative sign. Okay, and then my c would end up being nothing. So what's my equation? Y equals my a value, we said was 2, my amplitude, but we needed to flip it because sine's starting going down. So that's the thing that I would at least look for right now. Negative 2. And then what do we got? The b value is 1, so I can just say cosecant x. And then I'm just going to tack on a plus 1. There is no phase shift. Okay, the vertical shift is 1. Disregard that red line there, that's just part of my asymptote. Okay, so the black, y equals negative 2 cosecant x plus 1. So that's about as difficult as it's going to get. We will go through a whole bunch of these as we go through it in class, and come with any questions that you want to start the hour. I hope you all have a wonderful day.